Hello and welcome to this video about multiplying and dividing rational expressions. The learning target of this lesson is to accurately multiply and divide rational expressions. So we'll start off with the core idea here. The big thing that we got to keep in mind is just think fractions. And to treat rational expressions as fractions. Because at their core, that's really what they are. They just look different. And so keep in mind, these are just fractions with variables and variable expressions. So for example, let's say we had something like 7/12 times 3/4. How would you simplify this? How would you do the multiplication? It's going to be the exact same process. If you want to, you can multiply the 12 and the 4 and the 7 to 3. Or you could realize, wait a minute, I can simplify something here. I can take out that 3, make it a 1. I can take out this 12 and make it a 4. Or take the 3 out of the 12 and make it 4. And now I'm looking at 7 times 1, 4 times 4, 7/16. The mechanics of rational expressions are going to be the exact same. So sticking with that idea, let's take a look at a similar problem, 7/12, but now this time divided by 3/4. Again, if you're dealing with fractions, you have to do division. You have to do the whole keep, change, flip thing. So we're going to keep this fraction. So we'll have 7/12. We will change the sign to multiplication, and we're going to flip the fraction to be 4/3. And then just like we did earlier with 3/4, but now 4/3, we will reduce the 4 and the 12 to get 3 and 1, and then we're multiplying 7 and 1, 3 and 3 for 7/9. So in those mechanics for fractions are going to work the exact same way with rational expressions. And so let's do a couple of examples with multiplication where we're multiplying. Let's say we have 3x over 16x squared times 8x squared over 3. So it's all about organization, making sure you know what's been crossed out and what hasn't. And so I see right off the bat, the 3's can go. I see that these x squareds are going to go. But be careful, this x is still very much here. And then that the 8 and the 16 can reduce to 2 and 1. And so when it comes to multiplying, reduce early. It's just going to make your life a lot easier. And that's why for years, your math teachers probably told you, reduce fractions early instead of dealing with larger numbers, even though you can still do it at the end. It just is a little more tricky then. And this is why. So the 3 is gone, the 8's gone, the only number we have is 1, and then the variable is x, so we'll just write x. There are no x's in the denominator, and the only thing that's left actually from there is 2. So that one becomes x over 2. Now we can see the same thing with more complex rational expressions where we have polynomials. So something like maybe x squared minus 3x minus 4 over x plus 5 times the quantity x plus 5 over x squared minus 4x. So what we're going to want to do here is, I'll do this in a different color, factor, and just see what it is we have. So up in the top I have x minus 4, x plus 1, x plus 5 can't be factored, but I can take out an x from this one. So this is going to be x and then x minus 4. All right, and then I look diagonally, I see x minus 4's can go. I see x plus 5's can go. And what I'm left with is this x in the denominator and an x plus 1 in the numerator. And so x plus 1 over x, and that's as far as we can take that one. So that's multiplying. And multiplying, it's the same thing as simplifying. It's longer and kind of cut in half because you're doing, multiplication right there. For division, it's similar as well. You have one extra step, which is to change the sign and flip the fraction. So maybe 2 steps, I guess, technically. So let's take a look at another example. Call this example 3. 4x minus 8 over 2x minus 2. Oh, 1 second here. I shifted some things down there because I saw I was going to need some space. All right. And then 2x minus 4 over x minus 4. Okay, cool. So what I need to do now is take my time. Be patient. Don't try to cross off anything yet because we have to change this and we have to flip that. And so what I will do though is maybe I'll do some factoring right now, because like everything's kind of in a neat little spot, so I'll do that. All right, I can take a 4 out of here to get x minus 2. Awesome. I can take a 2 out of here to get x minus 1. I can take another 2 out of here to get x minus 2, and then that stays as x minus 4. So now, let's rewrite everything. 4 times the quantity, x minus 2, over 2 times the quantity, x minus 1, times, and I got to flip these. So this guy has to go into the denominator, and the other guy's going to the numerator. So x minus 4, 2 times the quantity, x minus 2. If you want to, it might be easier to do the flipping and then do the factoring. All right, now let's see what we have. That crosses out, that crosses out. The 2 and the 4 will cross out, leaving me with the 2, and then that 2 will cross out with that 2. And these guys stay the same, do not impact each other, so we have x minus 4 over x minus 1. Box it, walk away. One final example, just to show you again. So let's go with 4. All right, x squared plus 3x plus 2 over 12 divided by x plus 1 over x squared plus 4. All right, let's see here. So first thing I'm going to do the flipping, or keep change flip. So x squared plus 3x, and give myself a little more space to do this. Okay, so x squared plus 3x plus 2 all over 12 times by x squared plus 4 over x plus 1. Okay, let me see here. Okay, so the top one right here can break down as x plus 2, x plus 1. And that's it. Nothing else really factors in this one. This is not a difference of squares, so I can't do anything with that. That stays as is. So the only thing I can cross out is x plus 1 and x plus 1. And then everything gets multiplied together. And again, there's two ways we can write this. We could say this is x plus 2 times x squared plus 4 all over 12. Or I could FOIL it out, but I don't see any real need to FOIL it out, so I will leave it as is, like that. And so that is how we handle rational expressions with multiplying and dividing them. Again, all I can stress is that treat them like fractions. What you normally do with fractions is what you're doing with these. It just looks much different. Good luck with your homework, and let me know if you have any questions.